We are the Portable Mobility Assist Solution Team, a project within HSTEM Enterprise. LBFE, or Little Brothers Friends of the Elderly, is a local volunteer organization. They assist senior citizens with getting to and from their appointments. Typically, these are elderly individuals who are capable of walking but do not have the muscular strength to lift themselves up from a seated position or sit down. Often, volunteers need to help them, which poses a health concern. Hence, the requirement is aid elderly individuals getting in and out of vehicles. We are in the first phase of this 2-year project, which will span from fall 2023 to spring 2025. Based on this, our problem statement is the development of a safer method for assisting elderly individuals in standing up or sitting down in a vehicle.
At the end of this project, we will hand off our prototype to LBFE. A significant part of our project is making sure that the volunteers can easily use and repair it without requiring a large amount of training. We also want to make sure that it's not overly expensive, as this would make it less practical. It has to be all weather since this area truly gets all kinds of weather. And another necessity is that it is lightweight so volunteers can easily move and adjust parts of the model. So our team came up with 4 designs early on and used a weighted means chart to determine the best design based on the requirements and constraints. The design that was chosen was a seated lift device. The intended use for this design is only for next to the vehicle. The design would not be used to move the elderly away from the vehicle. The design would only be used near a parked car and not act as a way to transport the elderly a significant distance. The elderly would be put in the seated harness that we have designed. The device would then be used to help move the elder from the device into the car by lifting the seated harness. The device height can be adjusted and the chair rotated to safely position the elderly inside the car. The seat would then be detached from the system, acting as a cushion while in the vehicle. When the elderly wanted to leave the car, the chair could be reattached to the system and they can be taken out still in a seated position. The only movement the elderly would have to do is sit down and stand up. The novelty behind this design is that it is accommodating and can adjust for the height of the elderly and the type of vehicle. Along with that, the system would be safe for the elderly because they have minimal movement or have to use significant strength. It is safe for the volunteers because they don't have to physically touch the elderly, which is a liability and a chance that they get hurt when trying to help them. The team made an initial prototype to test the real-world feasibility of the design before moving to manufacturing and testing. Notably, it featured a U-shaped pivoting joint. This would allow for more movement and adjustment of the chair and elderly to get in and out of the vehicle. With the prototype, we made the chair and the frame of the design to determine optimization. Specifically, we looked at the design feasibility of the pivot bar and the width of the chair and the arms for comfort while also considering the dimensions of the car door and different car types. In addition, we observed the stability of our models. We tested by putting weights on the chair and seeing how the system reacted. We did not implement the lift device in this model because the team was focused more on the frame and pivot joint during this phase.
After creating the initial prototype, several areas of improvement were identified. Chiefly, after conducting more research into fabrication, it was determined that the pivoting joint would pose a large challenge. Specifically, it would require bending a metal beam to shape. Owing to the size of the material used, this would not only be expensive, but would require specialized equipment, limiting the opportunity to replicate the design and create multiple prototypes in the future. So, in light of this, the joint was removed for the second prototype. The initial prototype helped to visualize where weaknesses in the structure would likely arise. This included areas prone to high stress, pinch points, and sharp areas which could all pose a hazard. This all helped to inform the fabrication process moving forward into the second prototype. For the second prototype, these changes were implemented. The materials used for the frame for the second prototype included 80-20 aluminum, A36 steel, and the seat component was made of a gel cushion reinforced with a wooden base and attached to the frame utilizing nylon straps. These materials were used in the hope to avoid structural failure within the bounds of the design's parameters. After assembling the second prototype, additional areas of improvement were identified, most critically, the system's stability. Connecting brackets showed signs of stress and bending, which could lead to system failure. This can be improved by using thicker bracket material and tighter machining tolerances. Another weakness in the second prototype was the bulky design. Currently, there are several protrusions and other unnecessary material that could be removed in order to improve the ergonomics of the design. As material is removed, and the overall weight will be reduced, which will help to better align the prototype with our weight requirements. The final point of improvement centers around the need for the design to be portable. Currently, the frame uses several bolts and pivoting joints to break the frame down into more manageable pieces. However, these pieces are still unwieldy, and the extra parts will decrease the ease of use. Looking to the next semester, these weaknesses will be addressed. This will include research and problem solving to fix the stability concerns, weight reduction, and continued fabrication. These problems will be addressed so that testing may begin and the limitations to the design improved.
These are the standards that we referenced while designing our prototype. They came from ISO and ASTM. Over the first 2 semesters of this project, we have completed multiple steps ranging from design research to the build of our second prototype. For the next year, the team will continue testing, making more revisions, completing a final prototype, and handing it off to LBFE. During these 2 semesters, we created literature review, risk and safety assessments, a preliminary prototype design and creation, revisions, adjustments, and a second prototype design and creation. In the future, our goals are to increase the safety while decreasing the weight, increase the portability and compactness, and complete testing for comfort and optimization. We would like to thank the Visser Foundation, the College of Science and Arts, the College of Engineering, the Department of Cognitive and Learning Sciences, the Department of Kinesiology and Integrated Physiology, our advisor, Dr. Smitha Rao, Milwaukee Tools, the Enterprise Program, the Alley Makerspace, and Little Brothers Friends of the Elderly.